In this video, we'll take a look and see how to solve equations that involve both exponential and logarithmic equations. So let's start with exponential. Our first example, solving an exponential equation, means that the x is going to be in the power. So if we have to solve the equation 2 to the power of x is equal to 8, in this case, 8 is a power of 2. So sometimes if you can take a look and go, oh, 2 to what power is equal to 8? X is equal to 3. Okay, but what more commonly happens is you have something like 2 to the power of x is equal to 27 that isn't a power of 2. So the solution strategy for exponentials is to take the log of both sides and use the property of logarithms. So the property that we're going to use is if you have the log of something to a power, that means we take x times log base 2. So we want to be able to get the power, the x out of the power, and logarithm is what's going to allow us to do that. So the solution strategy for 2 to the power of x equals 27 is take the log of both sides. I'm going to take the common log because that's in the calculator. You could also take natural log. So I get log of 2 to the x is equal to log of 27. Now the reason for doing that is I can use the property and rewrite that as x times the log of 2 is equal to the log of 27. And then last, divide both sides by log of 2, and I get x is equal to log of 27 divided by the log of 2. So when you type that in the calculator, we get log 27, and I'm just going to close the parenthesis, divided by log 2 is equal to about 4.755. And if you want to check, take 2 to that power, and remember that we rounded, and see if you get approximately 27. So if I take 2 to the power of 4.755, I get pretty close to 27. All right, so next example, we have solved the equation 3 to the power of x minus 2 is equal to 5. Again, we're going to take the log of both sides. So I'm going to end up with the log of 3 to the power of x minus 2 is equal to the log of 5. And again, the goal is to take that x minus 2 out of the power and write it in the front. So now I have x minus 2 times the log 3 is equal to the log 5. Now here it's tempting to distribute, but don't. We're trying to solve for x. So divide both sides by log 3. And notice we're putting everything in the calculator at the end. I have x minus 2 is equal to log 5 divided by log 3. Last step to get x by itself is to add 2 to both sides. So I want to take log 5 divided by log 3 and then add 2. So in the calculator, we get log 5 divided by log 3 equals, and then add 2. So we want to make sure we've got order of operations. So x is about 3.465 to 3 spaces, and you can always check by taking x and substituting it back and seeing if you get that answer. All right, so the main technique for solving exponential equations is to, let me clear this out here, is to take the log of both sides and solve for x. And again, don't put anything in the calculator until you solve for x completely and then put the value in the calculator. All right, next one. This is a challenging problem that you have on My Math Lab, so I wanted to make sure we went over it. We have 0.4 to the power of x is equal to 8 to the power of x squared. So we're going to take the log of both sides. So I get the log of 0.4 to the power of x is equal to the log of 8 to the power of x squared. Next step, rewrite this using the property. We get x times the log of 0.4 is equal to x squared times the log of 8. Okay, I hate to say it, but this is a quadratic. We have an x squared term and an x term. Whatever the log values these are just constants. We can type them in the calculator. So the next step is to solve it like you would a quadratic. Get everything on one side, 0 on the other. So I'm going to subtract this x log 0.4 from each side and end up with x squared log 8 minus x times the log of 0.4 is equal to 0. Factor out an x. I get x times x log 8 minus log 0.4 is equal to 0. And now you can set each factor equal to 0. So x equals 0 or x log 8 minus log 0.4 equals 0. So x equals 0 is one answer. Solve the second. Add log 0.4 to both sides. X log 8 is equal to log 0.4. Divide both sides by log 8. And our solution is going to be x is equal to whatever we get when we take the log of 0.4 divided by the log of 8. So that was a complicated problem that involved factoring. So I just wanted to make sure we went over it. So we have log 0.4 divided by log 8. And our solution is about approximately negative 0.441 if we go 3 spaces. All right, so that's solving exponential equations. Next, we're going to take a look at solving logarithmic equations. And there are 3 strategies depending on what you're given. So the first strategy is, if we want to solve log base 5 of 4x minus 7 is equal to 1, notice we have a logarithm on the left, but we have just a number or an expression on the right. First strategy, rewrite in exponential form and solve. So exponential form says that that is 5 to the power of 1 is equal to 4x minus 7. When it's written in exponential form, it's a nice, easy linear equation. Add 7 to both sides. I get 12 is equal to 4x. Divide both sides by 4. X is equal to 3. And then we check and make sure 3 works. Can you take the log base 5 of 4 times 3, 12 minus 7? Yes. So x equals 3 is the answer. So that's the first technique. Rewrite in exponential form and solve if you have the log of something on one side equal to just a value or an expression. Next technique, next strategy. Notice you have log base 2x plus log base 2, 9 equals log base 2, 27. Each expression has log base 2. So the strategy here is to use properties of logarithms to simplify each side down to the log of something equals log of something, and then unlog each side. So if we take the log base 2x plus the log base 2, 9, use the multiplication property that says that's the same thing as log base 2 of 9 times x. And that equals the log base 2 of 27. Once you have a logarithm, nothing in front, same logarithm both sides, unlog each side. If the log base 2 9x equals the log base 2 27, then 9x must equal 27. Divide both sides by 9, x equals 3. So that's the second strategy. We have another chance to practice it in the next example. So notice there's something we have to do first in this example. We have a 2 out here. So we have to make sure that we write all of these with just natural log. So use the property that says 2 times the natural log of 2 is the same thing as natural log of 2 squared. You can bring that up and square it. Plus the natural log of x minus 4 is equal to the natural log of 32. So now we have natural log of 2 squared, which is 4, plus natural log of x minus 4. Use the property of combining these two. So that means that the natural log of 4 times x minus 4 is equal to the natural log of 32. Now that you have natural log of an expression on the left equals natural log of an expression on the right, you can set the two expressions equal to each other. 4 times x minus 4 is equal to 32, and solve your linear equation. Multiply through by 4, we get 4x minus 16 is equal to 32. Add 16 to each side. 4x is equal to, let's see, 48. Divide by 4. X is equal to 12. So then you check and make sure that it works. Okay, can you take the natural log of 12 minus 4? Yes. So it doesn't work. You can't take the natural log of a negative number, and that's when you get no solution, is if you were to substitute your value back in and you ended up with a negative. All right, last example is when you have to use properties of logarithms to simplify a side and then rewrite in exponential form. Okay, so now we have the natural log of x plus natural log of x squared is equal to 4. We have natural logs on this side, but we have to collect these or rewrite them as a single logarithm, so we're using our properties. Natural log of x plus the natural log of x squared is the natural log of x times x squared is equal to 4. So that says natural log of x times x is x to the third is equal to 4. Now we rewrite as of exponent. Remember that natural log is log base e. So that says e to the power of 4 is equal to x cubed. And then how do you get rid of a cube on x? You take the cube root of both sides, or you take each side to the power of a third. So x, the cube root of x cubed is just x, and we get e to the power of 4/3, or the cube root of e to the 4th. Either way, we can put that in the calculator. So if we take e to the power of parentheses 4 divided by 3, that's e to the power of 4/3, which is, to, let's see, round to the nearest thousandth, so we want 3 decimal places, is about 3.794.